Hi everyone, thanks for joining us. So today I'm gonna present the demo of this week on which things I have worked on. So this week I have worked on choosing the right model for our robot. I was exploring a lot of models to see which one will work better, and still I'm experimenting with the different models. I have selected the V3 Mini, but before using this model I have also used the OpenAI API key. So the thing was I gave all of the access of our robot to the OpenAI, and we'll see whether it will control our robot or no. And the results that I got was really impressive. If we can see the video of the robot picking up the markers, it was really impressive, the results. And then after using OpenAI API, so here we are controlling the robot completely from our AI model, but it's using the GPT and not using the small LLM model. But after this I have selected or choose the model of the V3 Mini. The reason why I have selected this model, it was because the model is really small. I wanna experiment the thing that whether the model can navigate or can control the robot to collect the markers or no. But the model did work really well, but it's sometimes it gives the abnormal behaviors. But with the guidance of the things how much distance is between the markers or other things, we can do or navigate our robot. Like here, as you can see, we are giving the prompts to our model. Here, the robot position, the current position, robot facing direction, target position, the spatial analysis or everything. The model is working really well with all of these things. But if we leave the model on its own, then it makes some abnormal behavior, he didn't decide where to go. But with these recommendations to the model, the robot position, target direction, the distance to a target, he did selects the commands to move the robot towards the markers. And yeah, it's working really well. But the main goal is to make the model in a way that he controls the robot by its own, not by using some algorithms to train the model that will control the robot by its own, not giving some guidance by using different algorithms how much distance is left. We want that the model think by itself which command to use, if I will use this command, then what's the better result. So yeah. And the other thing is we have made the architecture in a different way. For example, our AI brain, the model is on our server, and the robot controls or the commands is on our MacBook. So whenever we run the model, it's running on our server, and both of them are connecting with the TCP connection. We run the server, the AI brain, and our local computer is controlling the cameras and the robot commands. And yeah, the main thing is if we are thinking to fine-tune our model in the future, then we must need more resources, the more GPU power and the CPU power. So if we will make the architecture in that way, then in the future it will be more easy for us to fine-tune our model. So that's how our architecture works. And the problems that we are facing during all these things is first thing is the camera angle. Basically we are detecting our robot position from behind. For example, if we are having our camera over here and the robot is here, and if our marker is here, then our system thinks that the robot has already achieved or has already collected the marker. But in reality it didn't have collected the marker. For example, here, if we will see this video, for example, here our robot is away, but it still think that he has collected this marker, but it's really away from the marker position. For example, here where it's has saw the thing that the camera has saw that this marker has reached the marker that we need to collect, but it's so much away from the marker. So the main problem is the camera angle. We need to fix that thing. And I am thinking if we are if we track the robot motion from the overhead view, it will be more easy. Then the camera will be here and we will be like able to see like how much distance is between the marker and the robot. So tracking the robot from behind is like not a good idea. It's like if we will track the robot from the overhead view, it will be like giving us more precise the angles and the distance between the markers and to reach our target. So, and the other thing is like we are thinking to use maybe like two models. One is like, so our basic implementation of our project is like we will scan the drawings of any person and we will like come up with the rules, and the model is like controlling the robot and to achieve the scores or the goals. Like, yeah, so the basic purpose of like using two models is like we cannot train one model and like feed everything into the one model. Like one model will be like trained for controlling the robot and the other is like trained for like coming up with the rules for the drawings. And yeah, but in the future we are like thinking to implement the reinforcement learnings on the two different robots, not only on the one. So they will be like learning by their own instead of like training the model or like fine-tuning the model. But we have started from like using some pre-trained models and to see like which model is like coming up with the better results or which model is like coming up with the better navigation systems. So yeah, and the other thing I have like found is like the data set for the tuning of our model. Let me find. For example, here we are having the different drawings of like the maybe it's the of the children's. For example, here the rocket type of thing. This is like the one drawing, and yeah, and here for example we have a sticky figure of the person. So these are different drawings of the children or maybe of the adult person, but I am like thinking to use these drawings to see how our VLM or maybe any model will come up with the rules and how will our robot will follow the rules and to implement the things. So yeah, but the main thing or the basic or the most big problem is like to label these drawings. Like first, for training our model we have to label the drawings. Like first we have to tell our model like what's our rules are gonna be like, and by labeling those drawings and by tuning our model, then the robot will be able to make its rules by its own. So yeah, here we are like having 1700 different drawings or different people. So we can like use this type of data set to fine tune our VLM, like the vision language model, to make the rules for our model. And the other model is like gonna implement the moves of the robots by seeing those drawings and by seeing those rules. So yeah, any questions? On the server.
Which server?
The one that you have made. The drawings?
Yeah.
No, it's not like by myself. It's like I saw or I found this data set from the Hugging Face. One of the person has this data set. Yeah, that's what I found on the internet. It's not like made by me. Yeah.